says going live now, and it says you are live now. Mike, you can take it away.
Awesome. All right, so welcome to today's meetup in Cloud Native Aarhus. Today we have quite an interesting speaker. I've looked extremely much forward to see what he has to say about both Prometheus in its current state and the road ahead and the ecosystem and such. I've always had been very fond of the whole observability space and have been a fair power user, I would say, of Prometheus. So this is super interesting to me and hopefully all of you as well. So first of all, I mean, we just have this brief agenda. I will soon hand it over to Julius, and he will go through his presentation. During the presentation, we will monitor the Slack channel as well as the YouTube chat, and then you can post whatever questions you have, and we will then hand them over to Julius after his presentation, and we will see what awesome things he has to share with us. But first of all, I just want to briefly touch on who the team in Cloud Native Aarhus is. Yeah, I'm Mike, infrastructure engineer at Humio. We have Rasmus, CEO at Neurospace, and Kasper at Luna, and then also Henrik at Efficode Pragma. And they are all in the chat in case you have questions or suggestions for future talks or something in that regard. Yeah, so Cloud Native Aarhus is part of this larger Cloud Native Nordics, and we have quite a few different places so far, meetup groups. Maybe you haven't attended any before. I just wanted to share that we actually have quite a few of them in the Nordics, and if you live close to one of the locations, maybe it's cool to check out. Yeah, so today we have Julius. He is one of the co-founders of Prometheus, and he's previously worked at SoundCloud, where the origin of Prometheus is, and has also worked at Google previously. And more recent times, he has started PromLabs, and I'm sure he will tell much more about one of his interesting new projects that he's been doing during his presentation. And he's also been one of the founders, or the founder. I'm not sure if it was a team initially to kick off PromCon, but yeah. I'm sure many of you have already seen the abstracts. I just highlighted a few of the key things, and it's mainly around the ecosystem and making sure that we are, get better acquainted to the limitations and challenges that we see, and also, both for adopting Prometheus, but also for using it day to day. And yeah, he will also go through this PromLens project. I've not really looked into it yet, so I'm super excited to see what that brings to the table. And yeah, as mentioned during the talk, we will monitor the Slack channel on Cloud Native Nordics Slack. You can visit cloudnativenordics.com for an invitation if you're not already on there. And also the YouTube chat. And that's basically what I have. I'm not gonna waste more time. I just want to hear what Julius has to say. Sounds good?
Thank you, Mike. Sounds good. Should I switch and share my screen?
Yeah.
Awesome, I'll do that. All right, is that all visible?
Yeah, looks good.
Perfect. Okay, so yeah, thanks for the intro. Again, I'm Julius. I co-founded a bunch of stuff, and also I co-created Prometheus, founded PromLabs, and founded PromCon. I want to say one thing about my new company, PromLabs, just because this might be confusing. You know, Prometheus is a bit unlike some other open source projects that have one clear backing company. Prometheus is independent. It belongs to the Cloud Native Computing Foundation. Many companies are working on it and have voting team members in our governance. In PromLabs, I just established very recently now in the last couple of months. Just myself for now, no external funding. It's just for now a way to continue my own consulting around Prometheus in a more formalized way, while also giving me the ability to actually create commercial software around it. So, don't see this as PromLabs controlling Prometheus or anything. It's just myself at the moment. Cool. So in this talk, I want to go a bit into where Prometheus was coming from, what we're currently doing, and then maybe, what are future considerations for different challenges that we're facing. Just for people who have no clue about Prometheus yet, I hope that most people watching this talk are already somewhat familiar with Prometheus, but just a very brief overview of the rough architecture. Prometheus is a metrics-based monitoring system, which you run as individual servers in your infrastructure. So you would have one or multiple of these Prometheus servers in your infrastructure, and they would talk to some kind of service discovery mechanism in your infrastructure. This could be the Kubernetes API server or a Chef server or any zookeeper or other kind of central authorities in your infrastructure that know where your different machines and your services are living, with what should be there, what identities do they have, is it a prod, pod, or a staging one or so. And then based on this information, Prometheus can dynamically discover all these different things in your infrastructure that you want to monitor, which we call targets. And either they're directly instrumented with one of our client libraries, or there's some third-party device that you cannot directly instrument with Prometheus metrics. And then you would put a little agent in between that does the translation, which we call exporter. And this whole collection of metrics is happening over HTTP via pull in a text-based format that Prometheus defines. Prometheus then collects all that data in a time series database, makes it available for querying, either through a built-in web UI or Grafana, which is the most common way to build nice dashboards on top of Prometheus. And Prometheus also has the capability to calculate alerts based on the data that you collected, and then dispatch them and route them to a separate component called the alert manager. So, the main selling points I always mentioned about Prometheus is really this new kind of dimensional label-based data model in comparison to hierarchical data models in Graphite and StatSD that came before, combined with a query language that allows you to do really flexible computations on the collected time series. Then the service discovery integration, for the first time, really enables the monitoring system to work well with dynamic environments. And this became really, really relevant when Kubernetes came out, because how with a statically configured monitoring system, how do you want to tell it what should be currently living where, what pod should be running where, and so on. It is not a clustered, horizontally scalable system, but it's still very efficiently implemented. So you can have multiple independent nodes, each being quite powerful in terms of how much data they can collect and process. And then again, in contrast to monitoring systems like Nagios before, you have alerting integrated with all this time series data collection and processing. So you can write alerts in the same language that you would use to write dashboard expressions. So a bit about the journey. Prometheus started in 2012 when Matt Proud and myself left Google, joined SoundCloud, were tasked with making SoundCloud more stable, but they had a cluster scheduler in 2012, nobody had heard of. Even Docker didn't exist, Kubernetes didn't exist, but they had built their own container-based cluster scheduler. And we were like, oh, how do we monitor this? It's impossible because it was so dynamic. And we were really missing Google's Borg monitoring system at that time. So inspired by that, we we created something similar called Prometheus and made it open source from day zero, and like gradually introduced it at SoundCloud. It took a couple of years to actually become useful. So we you know, it was open source, but we didn't really talk about it. And so we only fully published it in January 2015, saying like, okay, it's stable, it has enough integrations, it has a documentation site now, which I really worked on feverishly. And yeah, it was actually really well received, especially because Kubernetes was coming out at the same time. And so the two really went well together. We joined the Cloud Native Computing Foundation 1.5 years later. This foundation was like very new at that time. Kubernetes was the only project in there. It was kind of created for Kubernetes. You know, Google wanted to have a neutral home for Kubernetes, and but we joined as the second project, fitting into this whole cloud native landscape. Very briefly afterwards, we released the first 1.0 of Prometheus, just to signal that it's now relatively stable and you can actually use it in production. Then we founded PromCon, and by now we've had 4 or 5 PromCons in Germany. We wanted to have a PromCon North America in Vancouver this year, but obviously Corona, so that's not happening. But there's going to be an online PromCon in July. There were still so many things we wanted to fix after Prometheus 1, and a lot of them required breaking changes. So end of 2017, we released Prometheus 2. And like there were many things that we changed, little things, bigger things, but the biggest one was the storage engine. So for Prometheus 2, we completely rewrote the storage engine that was actually based on the idea of one person, Fabian, back in the day. And this new storage engine really, you know, improved everything by orders of magnitude in terms of resource usage, and especially dealing way better with changing time series identities over time, which is a really big problem on Kubernetes and so on, where you scale up pods and scale down and you have time series appearing, disappearing. So every day there will be even a whole new set of time series, or every couple of hours even, and you want to index them efficiently over time. Since then, things have been relatively stable on the not breaking things front, but there's been just a million additions and everything has been made more efficient. The team has grown, everything is more active than ever. So yeah, it's really, you know, widespread so far. I always like to include this GitHub star graph just as a joke, but it, you know, tells you a bit about the growth. It doesn't even show the initial years where nothing happened, like when it was just at SoundCloud, and then there was this big bump. And so initially, you know, you had this exponential growth, it went into linear, and now Prometheus is like at 30K GitHub stars and very well adopted throughout the industry. And so gradually we're like exiting this linear phase and going into the logarithmic part of this S curve of the growth. But let's see, you know, you never know. Sometimes it picks up again or so, but you know, it just shows that it's relatively mature by now. Here's some stats, which I won't all read. Couple things that are important. Again, what I said initially, we're 20 voting team members. They're from companies such as Grafana Labs, Red Hat, SoundCloud, PromLabs, Robust Perception, Splunk, and others. So it's a very varied team from different companies controlling the project's direction. And yeah, what was really important and really helped us at the beginning was this native support for in Kubernetes. So Kubernetes very early on said like, oh, that's kind of like Borg-Mon at Google. That's handy. Like we want to have support for that. And they very early on added native Prometheus metrics output into all of the Kubernetes components, the API server, the kubelet, and so on. So that was one thing that really helped. And yeah, by now it's, you know, it's adopted by small startups to big enterprise companies. So let's look a bit at what is happening right now and what are some challenges that we're facing and where we are taking Prometheus. So first of all, like Prometheus at its core is not going to completely change. We're still going to focus on being a metrics only monitoring system. There's other important stuff in the observability space like logs and traces and other tools. But Prometheus focuses on numeric metric-based monitoring. And especially on this kind of live monitoring for systems and less on like business use cases or user tracking or this kind of thing. So focus on operational systems monitoring. We don't really do very deep machine learning style statistics, and also Prometheus servers are, they're not a horizontally scalable system, so they themselves are somewhat limited in their durability and long-term storage if you're limited to a single node. Then again, I put asterisks next to these last 2 points because there's some people who want to add more statistics functions to Prometheus, but the jury on that is not out yet. And some people would also say, no, Prometheus is actually really good for long-term storage because some people keep many years in just the local storage and back it up very carefully. So it depends a bit on how you look at it, but it's not a horizontally scalable system. But still, within these constraints, there's still a lot of things we can improve on. So again, back to the architecture picture. There's the first part, gaining more instrumentation adoption so that Prometheus can natively pull metrics from more things. How do we how do we enable people to do long-term storage with Prometheus, even though it's just these loosely coupled single node systems? And then PromQL is a pain. How do we make it easier? How do we make it easier to use the query language that we have? And so you can actually make the best use of your data. So let's look at instrumentation adoption first. Prometheus defines this text-based format, which is pretty good for exposing metrics over HTTP, but it's always been called the Prometheus metrics format. And then if you want to get some people to implement it directly in their devices, especially if they're conservative vendors like network device vendors, Cisco, Juniper, or so on, they might be like, no, that's vendor lock-in. We don't want to add something that's not a super duper internet standard. And you even find this in other open source projects where they're careful. They don't want to add just one specific vendor locked in standard. But realistically seen, Prometheus, the Prometheus metrics format is so widely adopted these days that it was a good base for actually basing a standard proposal on it. So there's a group called Open Metrics, created by Richard Hartman in collaboration with Google and Uber. And all this is about is evolving the existing Prometheus text format for transferring metrics into an open standard. And now you might be wondering, how does this relate to the Open Telemetry project? Because there's like Open Metrics, Open Telemetry, there was Open Census that got merged into Open Telemetry. It's very confusing. And Open Metrics really focuses only on this exposition format, like how do you transfer metrics over the wire, whereas Open Telemetry is all about the internal APIs, not just for metrics, but also for logs and tracing. How do you instrument a process? And then the output format in OpenTelemetry might actually be Open Metrics, which is this evolved Prometheus metrics format. So this is one of the possible output formats that OpenTelemetry will support. So the idea is then you really only instrument your processes once, and then you could choose, you could set the output format to StatsD, Graphite, or InfluxDB, or Prometheus, or Open Metrics. And we also see already on the vendor side that many people are starting to support collecting Prometheus or Open Metrics. And Open Metrics is not completely finalized yet, but there will be an announcement, I heard, like in the next couple of months about a spec actually being released and being finalized. So yeah, we hope that this will even give us even better adoption. So about scalability and long-term storage, Prometheus is a single node system, even if you run multiple of them that like loosely talk to each other. They themselves don't really replicate data gaps between each other and so on. So you're somewhat limited in your durability and scaling. And the attitude in Prometheus has always been, let's help others solve this for us, especially the long-term storage and durability aspect. And this won't be addressed directly in the core of Prometheus. So what Prometheus gave to people is a generic protocol with which it can write any samples that it connects to some remote system, which can then write into InfluxDB or whatever, like other long-term storage clustered system. And sometimes these two boxes are just one if there's native support in the receiving database. So this is actually becoming the more common case, that you don't have to like run a separate adapter to write it into the remote long-term storage. But this way you can just like offload all the samples you collect, still have local storage, but then also replicate it to some long-term storage. You can also read it back through Prometheus from the remote storage and then do PromQL calculations on the read back data if the remote end doesn't support this natively. And there's been some recent optimizations in this whole read and write path. And the most notable ones here are these two. So the whole replication of samples from Prometheus to the remote end has been a huge memory hog and generally resource hog. And there's been many optimizations going into that, like interning strings and just generally saving memory here and there. And one thing that really helped was instead of enqueuing all these samples in memory for each remote write queue, we would just read them off the write-ahead log that already existed in the local database anyway. So they can just reside on disk until Prometheus finds time to actually send them over. And this is usually happening within a couple of seconds, but the ability to not do this in-memory queuing, but just tailing off the write-ahead log also made it much more reliable. So if you now have a network outage for like 1 hour or something, then Prometheus at the end can still say like, oh, wow, okay, I actually tracked what was the last timestamp I sent from the wall, and I will just replay all that old stuff that I haven't sent yet. So you have some time window of protection against network outages, whereas previously, after a couple of seconds or minutes, it would just drop samples on the floor. Also on the read side, if you want to read back stuff from Prometheus through Prometheus from the remote end, you would initially had to like read all the data back to Prometheus and then do the PromQL, and now you can read it back in smaller chunks. And so time slices. So that really helps in terms of how much you have to transfer at the same time. In general, this whole ecosystem integrating with that remote interface is really evolving. These are just a couple of examples. Some of them are really open sourcey and closely related to the Prometheus project, like Cortex and Thanos. And then others are more commercially backed, like Timescale, InfluxDB, and so on. Thanos, I drew the arrow a bit differently here because it doesn't really currently use this interface. It uses, it integrates more directly with Prometheus to directly ship blocks from disk to long-term storage. So this is a quite evolving space and exciting to see what's happening there, but no one clear winner or so. Okay, let's talk about pains of PromQL. So I don't know how many people here have already dealt with PromQL, but if you enter a semi-complicated expression into this built-in expression browser in Prometheus, you can easily get a bit frustrated because there's no syntax highlighting. It doesn't really help you build the query in any way besides like very rudimentary auto-completion at the very beginning for metric names if you haven't typed anything yet. And then if you have a complicated query and it returns an error like this one, you don't really know where in this expression this error is happening. Is it happening just in a particular sub-expression or where exactly? And if you're not familiar with the language, you might also just generally be wondering like, what is group right or ignoring? And if you're working with this data and building queries, and then combining one query with another, with an operator, you really kind of have to get a sense of what data you're working with in different parts of this query, and it doesn't really show you that much. So you have to do like a lot of manual probing and copy and pasting. Also in December, I knew already that PromQL is a pain, but I did ask on Twitter what people's biggest pains were with Prometheus. And there were a lot of responses about, long-term storage and this and that, but the biggest cluster by far was PromQL. So you can see an excerpt of many of the PromQL frustrations that people had, either about it being difficult to understand or difficult to work with data, even if you are an expert, and nuances between that. So a couple of things that already aim to help a little bit. Grafana is doing really amazing work in general on the visualization front. And they have an explore mode now, which goes a bit beyond their typical, just the dashboard panel expression entry, where they already had auto-completion and syntax highlighting. This now also allows you a bit better to explore different PromQL queries next to each other, shows you the actual types of metric names that you're typing, shows you some inline help for functions while you're typing. It does not yet give you deeper insight into the different sub-results of sub-queries and explaining the meaning of different elements so much. Another really exciting development that's been happening is a Red Hat intern working on PromQL language server protocol support. So the language server protocol is a standard by Microsoft to standardize how editors interact with the language and show you type hints and help and so on. And this is already like working pretty well experimentally, but now it needs to be integrated into Prometheus and Grafana and other tools that work with PromQL. And then you can get really awesome auto-completion, error indications, like this one here, the squiggly lines, or even like inline help for functions. So I'm really excited about that. There's currently still more integration work happening about that. And then finally, my vendor plug. So PromLens is a tool I've been building over the last months that aims to give you this deeper insight into PromQL query. So, on one hand, you enter a PromQL expression and it really lays out the whole expression structure as a tree, showing you the number of results and the label dimensionality at each subnode. So you really get a sense of the data you're working with. You can click on any subnode and then immediately see below, either as a table or graph or an explanation view, like what this node does and what data it selects. I will do a demo of this later on, so I won't go like too deeply into this now. But it also has a form-based editor. So, this makes it easy for people who don't remember all syntactical constructs of PromQL to just click together a query. And you can actually already run it locally. There's a free version that you can just run with Docker run, and then you kind of locally enter a Prometheus server at the top that it speaks to, and you can use PromLens against it. Then there's a version that is going to be commercial. I'm not fully set up for all the payment stuff yet, but it has a Grafana data source picker and a link sharing functionality. So if you use it in the company, you would just point it at your Grafana installation and you could choose from all your Prometheus servers in your Grafana, and then also be able to generate shared links that you send around in Slack or so. And there's way more stuff in general in the Prometheus ecosystem. So other stuff that's happening is, so far we've always said like, hey, when Prometheus pulls data from targets, it does support different TLS and auth and basic auth and cert auth, etc. options. But all the serving endpoints that Prometheus components give you directly, like the Prometheus server, its endpoint, and the alert manager, HTTP endpoint, and exporters, they didn't offer serving endpoints that have built-in authentication and TLS. And we always kind of shied away from this whole security topic, but now we are actually we're getting security audits of an initial implementation of built-in auth in TLS in the node exporter, which is one of the key exporters of the Prometheus ecosystem. And the plan is, once we have good experiences with that, to spread it to all of our serving components. So Alert Manager, Prometheus, the exporters, at least the ones written in Go, will all have at least simple support for the most common TLS and authentication options. So, previously you had to put an Nginx or something similar with TLS and auth support in front if you wanted to have that, and now you don't have to do that anymore. The local storage so far, Prometheus only really supported pulling in data at the current timestamp and a small window previous to that with some tolerance, but it didn't really support adding older data that's older than a certain amount of time, or even within one series to insert a sample that was before the one that you just added. And so there's work going on in that whole area to be able to add older data to your TSDB. Like if you have an existing monitoring system and you want to migrate some stuff into Prometheus. And also recording rules, they currently only start, like their way to pre-record some PromQL expressions into a new metric name, but they currently only start recording from the timestamp where you actually added them to your Prometheus server. And like you don't have history for what they would have been if you had added them like a month ago. So there's work going on retroactive evaluation as well to backfill rule evaluations, basically. We want to, like, we don't do tracing ourselves in Prometheus, but we want to play better together with tracing implementations. So one important thing is if you do have metrics and you have traces, you would like to sometimes start with metrics telling you like, hey, this histogram is showing you that this one endpoint is getting really slow. And it might show you that a certain number of requests are in a really slow latency bucket. And it would be really nice if you could then jump from that metric telling you like, hey, this slow latency bucket has a lot of requests. Like, okay, give me an example of such a slow request. And there's going to be support in Grafana for jumping from a metric showing an exemplar where you can click on. So you can click on histogram bucket saying like, okay, take me to an example trace of such a request, and it will jump over to whatever tracing system you have. And the way that works is that open metrics will support outputting like in the same line where it sends a histogram bucket, it will support a little comment pointing to a trace exemplar ID. So the ID of a trace that fits into that bucket. And then Prometheus records that. And then Grafana and other tools will be able to, that's the plan at least, will be able to query this exemplar and then help you jump to the right tracing view. Prometheus also is gaining support inside for tracing what is going on in the PromQL evaluator. So tracing what is happening inside Prometheus itself. Currently, it can only send its own traces to Jaeger, but the plan there is like once open telemetry and all that is finalized, that there will be like a standard format for outputting those traces. Then other future considerations that are a bit less clear whether they'll be happening or not, and some might definitely require Prometheus 3.0 because they will be breaking. But there's the idea to make more use of like first-class metric data type support, meaning like a histogram is not a bunch of flat series as it's currently represented, but like its own completely efficiently, separately represented type in the database and in PromQL. But yeah, that is the thing that definitely would require Prometheus 3.0. Same thing for better histogram scalability. Currently, you have to define static buckets for histograms, and often they're not quite the optimal distribution for tracking for tracking the latency profile of your application. But then if you add too many buckets, each bucket creates one series multiplied with all your other dimensions. So there's ideas here that Björn Rabenstein is working on to make these histograms more dynamic and sparse, but it's statistically quite complicated and also hard to integrate into the current Prometheus. So if this is going to happen, it's probably also going to be likely more of a Prometheus 3 thing. And yeah, there's people wanting to have a bit more statistics functions. Like Prometheus is pretty lightweight on the statistics at the moment. We do rates and deltas and increases and derivatives and a bit of linear prediction. And there's even a whole winter's seasonality predictor function in there, but it's very simple. And then we tell people, okay, yeah, if you want to do more complicated stuff with Prometheus, you have to pull the data out and then you use R or something like this to do more complicated stuff. And at least there's people, proponents in the team that would like to add some more statistics functionality directly into PromQL. Yeah, there's some more things that can be improved in the efficiency of the transfer interfaces between Prometheus and remote systems. And Cortex and Thanos have a pretty large overlap with the Prometheus team, but then also they're friends, like we're all friends, and they're already talking about sharing more code. And so there's probably going to be more and more integration of Prometheus with Cortex and Thanos, or at least between Cortex and Thanos sharing more and more code for their long-term storage, because they're doing a lot of similar stuff. And they're like, okay, why should we all implement this twice? Cool. So, oh yeah, one more thing. So Prometheus is always just going to be a puzzle, piece of the puzzle, only the metrics. So the whole integration with logs and traces, we are kind of leaving to other people. Like we're helping on the side of providing exemplars, for example, for traces. But other people like Grafana Labs and all other hosted monitoring providers, they're working really on integrating these different signals together and being able to jump from one to the other. And we're just kind of trying to make that a bit more possible. Cool. So I will do a brief PromLens demo, just so you see what it looks like, not just from a screenshot, but using it for real. So you can use PromLens, the free version, on just promlens.com, and you point it to Prometheus server here at the top and then start using it. But I will just use a locally running version, which has the Grafana data picker support, a data source picker support, just so you can see that. And yeah, I'll just play around a bit and show you some features. So one query that I would like to explore, not because it's super interesting in itself, but it's easy to show off some PromLens features with it, is taking all the per mode CPU usages and dividing them by like their total usage per core. So I'll start out with like a little snippet that's predefined that already almost does what I want to do. And I'm not going to explain PromQL fully now, because that's a bit beyond the scope here. But oops. If I evaluate this query, so I type it in here at the top and I press enter, I get a laid out version of this query. And now I can see the different sub results. And if I hover over here, I get an explanation of this. I see how many results in total there are at every subnode, and can select the subnode. So I see what data I am working with in the different parts of the query. And then here I only get one result. But really what I want to get is, I want to get one result for every mode, like mode idle, mode IO wait, and so on. So I have to preserve the mode on the left-hand side. And actually, I think I will. So I will also preserve the job label just for good measure, and maybe the CPU. Yeah, I will do that as well. And now there's different ways I could edit this query. I can do it up here, or I could use the form-based editor, which you can also just open with, oops, still focused up there, usability. I press E, get the form-based editor, And I say, okay, well, I want to actually preserve the job label and I want to preserve the mode label. And yeah, let's do it like that for now. And now this expression up here needs to be updated to reflect my visual edits. And now I get 0 results in this binary operator. So immediately I see there's a problem where it is like, oh, I get all these results here and here, but this is empty, and why? So I can now explain the binary operator. Sorry for the hammering above me. I don't know if that's audible. And this shows me why this binary operator is not generating any results. So by default, if I divide one whole set of time series by a whole another set of time series in PromQL, this binary operator will try to find elements on the left-hand side and the right-hand side that have identical elements and identical label sets. And in this case, I have the job and mode label on the left-hand side, as you see here. And here I have no labels. And actually, let me change that a tiny bit to at least preserve mode.
Sorry for interrupting, Julius. Can you zoom a little bit? People in the chat are having a hard time seeing the screen.
Hopefully it's a bit better now.
Yeah, it looks a lot better.
Okay, you can see a bit less then, but yeah. Okay, so I can see all these sub results, but also now I get an explanation telling me like how do these things match. So I have the job equals node label over here, and then other time series on the left-hand side that have the additional mode label. So the label sets are not identical, so they don't find a match. This one doesn't find a match on the left-hand side, and these don't find a match on the right-hand side. So we're like, oh, okay. So I want to tell PromQL to only match on the job label and not mode. So I could say like ignoring mode or by job. So I could again edit it in different ways. I'll show one more way to edit a node is you can edit any node inline by just pressing T and actually editing this whole structure inline. You can do it for any sub tree. You can just directly edit it as PromQL. But here again, let's do it with a form-based editor. I want to only match on job. So I say, okay, match on specified labels, job, apply, close. And now I get an error here because I have 8 series here that are joined with 1 on the right-hand side. So it's kind of a many 2-1 match. And if you want to do that in PromQL, you need to do it explicitly. You need to say it on this operator, saying like group by the extra dimensionality on the left. So you have to say group left. And I already see, like normally I would just get this error and I don't know if it's happening like here or there. And here I see it's like happening on this node. So again, opening this editor and saying like, okay, well, I want to have, actually, let's do it the wrong way around first. Let's say one too many. I would again get an error at this node and I would get an explanation giving me some hints how to fix this. And in the future, the idea here is to make this a bit nicer, even maybe give you some buttons to auto-fix according to common suggestions. And now if we do it the right way and we say I want to have many 2-1 match, then this should start working. And we see this, this assignment, like anything that has job node matches anything that has job node over here, and it's a many 2-1 match. And we could even preserve more labels, which could be interesting. Oh yeah, now I also need to job mode CPU, and here I need to preserve the CPU dimension. So now you see more groupings going on here and showing you how this binary operation matching is really working. So this is an area that really confuses people typically, like, oh, why am I not getting any output? And visualizing that hopefully helps a bit. Yeah, but like other than that, of course, you can show stuff as graphs, the different subnodes. There is other functionality where, for example, you want to build a query and you want to calculate a quantile estimation from a histogram, but it's kind of a convoluted query that people have a hard time remembering. So I have a couple of pre-canned snippets in here. For example, doing exactly that, calculating a quantile from a histogram. So if you apply this to the tree, you get kind of this pre-filled out query where you only need to add some components. So for example, the target quantile. And again, like actually, if you click on the function name and explain it, you get a whole function documentation. You get that for any function you click on. And also for any other node, telling you exactly what this node actually does. So in this case, if you're a bit unsure about the meaning of these parameters, you would just click on the function and get a bigger explanation. But yeah, so I could now say, okay, well, I want to set the target quantile to 0.9. And I can keyboard navigate, by the way. So I can set the actual histogram that I want to calculate to some thing. And now I have histogram quantile estimation. And yeah, I think the last thing that I can demo, besides, you have keyboard shortcut help here and so on, is the sharing functionality in Grafana data sources. So you can create shared links. And, now if I reload this page, it just, the whole state of what was selected is being persisted and shared. So this is very good for just sharing with colleagues, either from a beginner to a more advanced person, like, oh, can you help me with this query? Or then the other way back again, like, oh, look, this is how it works. And yeah, we can select different data sources from Grafana here. So for example, I could choose the robust perception demo Prometheus server, and then it evaluates the same stuff against that server. I'll zoom out a tiny bit. So you can see that the graph result will actually look a bit different depending on the server that you select. Cool. So that is PromLabs. PromLens, the company PromLabs is still being set up. Like there's some delays in the bank account, everything due to Corona. And so currently, if you want to trial the commercial version with the Grafana data source picker and the sharing functionality, just write me an email at either you can write to info@promlabs.com or julius.volz@promlabs.com, and I can give you a trial license for 30 days or so. And then later on, I will come up with the actual commercial terms for that. Cool. Let me just unshare my screen. God, I can't even find the button for that anymore. It's kind of hidden now. Huh, I don't see it. That's interesting. Ah, here, stop sharing. Cool. Yeah, there I am again. Thanks for listening. I hope this was interesting. And yeah, let me know if you have any questions in the Slack channel, I guess, right?
Awesome. Thank you, Julius. Yeah, first of all, questions can be put into both the YouTube channel or the YouTube chat and the Slack channel as well. One of the things that was mentioned was the scaling story around Prometheus and sort of curiosity about if it is where it should be, both in terms of the storage and scraping tons of endpoints and stuff like that. Do you see Prometheus changing in any way to make it easier to scale even further with Prometheus itself, or do you still see it as a building block for, Cortex and Thanos and stuff like that, and then not necessarily optimizing for a single instance setup?
Yeah, I mean, first, many companies will actually be fine with just a single beefy big Prometheus server. But at some point, yeah, if you have too many things, you will run out of capacity. A single server can do a couple of million time series that are tracked at the same time. But yeah, as for the whole horizontal scalability, in Prometheus itself, the main server, this is probably not going to happen. Cortex is already kind of a re-envisioning of Prometheus as a horizontally scalable and multi-tenant system. and it reuses a lot of the Go packages that Prometheus has. So there's already a lot of overlap between, like, in the teams of Cortex and Prometheus, in the technology, but it's kind of almost like a different way of distributing Prometheus. So it is already kind of almost that. But then for Cortex, it's more complicated to run because you have like this hashed ring of ingesters that keeps track of the recent data before it gets written to like a long-term storage in the cloud. So there's some trade-offs in the simplicity of the architecture that you need to run. And if we pull that into Prometheus itself, then we would have to deal with it there. So, at the moment, it's, if you want that, use Cortex. But the one challenge is still the ingestion path. So Cortex itself cannot pull data yet. So it's still, it's this cloud-based centralized system where you send your data, but you still need to run an on-premise Prometheus agent that scrapes, like discovers, integrates with your service discovery, scrapes local stuff and sends it to Cortex, whether it's a local Cortex installation or one that's like given to you by Grafana Cloud or another vendor. And so then you still have this way, potentially this issue, not like how do I scale my storage, but the collection layer, at least locally, right? And you can have many Prometheus servers kind of functionally, manually sharded by a different data center, by types of service. But if that becomes too cumbersome, there's another project created by Grafana Labs called the Grafana Agent, which is a thing that runs in your infrastructure. And the only things it does is, well, it's basically, it was a fork of Prometheus, but they removed any long-term, like any functionality for like querying and alerting and any of that. The only thing it does is actually collect and forward data. And then they're also doing it in such a way that it's supposed to be better horizontally scalable. So you could run it on every node and then it kind of service discovers everything, but every agent on any node sends only the stuff that's running on that node. So it kind of automatically horizontally scales with your nodes while still doing service discovery and attaching the right time series labels to the things it collects. Yeah, so that might be an option. There's other people building similar agents. Like many of these cloud vendors have their own agents that collect stuff in the Prometheus format already. But for me, always it's really interesting and important if there's this service discovery integration that Prometheus also has, right? So that it can tag, it can label and discover in the correct way.
We got a question in the chat on YouTube relating to this. Will Prometheus be creating scraping agents to offload the server? So that's very much in the same area that you just mentioned.
Yeah. So that's kind of the Grafana agent at the moment. And maybe Prometheus will have more native functionality for that in the future. There was in Prometheus 1, you were even able to completely turn off the local storage and just have it like work as a forwarding agent. And that's currently not possible due to the way the 2.0 storage works. And there's no current way work on making Prometheus itself modular enough that you could just turn it into a horizontally scalable scraping agent that doesn't do anything else. But there might be in the future. But yeah, it's not currently super duper on the roadmap.
Awesome. So you mentioned that in many cases this single instance would be enough for many people because it does support quite a lot of time series. How do you see the storage for that instance then? Will it always be local storage, or is there any evaluation of object storage type of things to implement in or support from Prometheus itself?
Interesting question. Yeah, currently there's always been ideas, but I haven't heard a lot about it. Like adding object storage support directly to Prometheus. The closest thing would be Thanos, which is pretty much, the most popular on-premises long-term storage solution that you run kind of as sidecars next to your Prometheus servers, and the sidecars upload the blocks to object storage, and then you have a query component for Thanos running in your infrastructure that integrates all the recent data from Prometheus servers with the long-term storage data, and adding that functionality directly to Prometheus servers. Yeah, that is something that could be interesting, and I'm not sure yet if that's going to happen at some point. But yeah, at the moment, you're kind of just mostly limited on local disk space. So like if you keep years of data, if you don't scrape that much data, it's already possible. But at some point, your disk will be full. that's like the limit. Yeah, and of course the durability. But yeah, so not currently planned. Maybe at some point, but yeah.
Cool. We have another question, which actually is the reason for this whole webinar thing, Tech Talk, which was a discussion on our Cloud Native Slack around where do you place alerts? And we would actually like to sort of hear your opinion. So do you place them in Grafana to get the visual alert thingy, or do you do them in Prometheus, Alert Manager? How does you see this whole space?
Yeah, I'm a big fan of Prometheus native alerts, but I'm biased. The thing is in Grafana, and they're very aware of this because I also have a lot of Prometheus people, the current Grafana visual-based alerts are relatively simplistic in their features and their routing, and you cannot make full use of the dimensional data model and alert manager routing and all that we have in Prometheus to group things by label dimensions and over time and all that. So they already, I saw a design doc about, like, I think more than a year ago, about making alert manager, making alerting in Grafana be more Prometheus-like. So it was basically a document like, hey, we should have a visual editor for Prometheus style alerts and routing. So I mean, it's nice to have this UI where you see simple thresholds and so on, but Prometheus alerts give you a lot more power. Yeah, so, and I also personally prefer configuring alerts in a source-based system in text format, though there has been a UI attempt to also in Prometheus make it more easy to play with alerts based on the historical data that you have already collected. So you could, and I hope we will revive this at some point. It kind of got lost, this PR, where there's an interface, you plug in your alerting expression and your for duration and all that, and you would see over time where it would have fired. But yeah, currently it doesn't exist. Still would recommend going the Prometheus way.
All right, so we have a question from Hans on Slack about this PromLens tool you showed off, because he also thinks that it's pretty useful and awesome tool. And he was asking about if it, I mean, how the free version of, basically how the free version of PromLens, if it would make sense to integrate it into Prometheus itself instead of having a separate project for it.
Yeah. The problem is it's free as in beer and not free as in like open at the moment. So that's kind of the downside. I decided to start closed first and then maybe decide to open parts of it later, rather than, doing it the other way around, because then you piss a lot of people off. So I haven't decided yet which parts of it will be open at some point. But at the moment, if I open it completely, it would be relatively easy for people to just add the missing features. And I mean, maybe I will decide that in the next couple of months, I guess, what will happen. But yeah, I mean, obviously it would be really cool to have it in Prometheus. But it's sort of my first exploration of commercial software, and I want to see where that goes first.
All right. So we also have a question previously from the YouTube chat. When you talked about this exemplars from Prometheus and tracing experience in Grafana, would that, how do you see that compared to something like APM solutions? Is that in the same ballpark, or?
I have no idea about APM solutions other than it means application performance monitoring, and that people count Prometheus as part of that. So I'm not sure about the question exactly. But I guess maybe if they do such a thing, such as integrating different signals with each other and jumping between them, which is becoming more and more interesting these days. But yeah, it depends, I guess, on which specific APM system you're talking about.
All right. I don't think we have too much more time left. You're already
Also
a bit over time. Any final words from the people on the call?
Yeah, I just think we should round off and say thank you, everybody, and thank you for staying 15 minutes more than planned. Julius wasn't sure about he could talk this long, but he did good, I think. I at least learned a lot from this. So yeah, thank you for joining, and please let us know, join the Slack and let us know what you think. Is this format good? Do you want more of it? Should we change something? Stuff like that. So thank you all for joining us, and goodbye.
Thank you. Bye-bye. Are we offline?